All right, you guys, we're going to look at the try it for example 3 from lesson 7.3, which is finding the area of trapezoids and kites. Remember, we're decomposing or breaking them apart into familiar shapes such as parallelograms, which are rectangles, squares, rhombuses, any four-sided shape with, let's see if I can draw this neatly, with two sets of parallel sides. So here's an example of a parallelogram. And um, we are also breaking them apart into triangles because we know the formula for the area of parallelogram, which is base times height. And the area of a triangle is always going to be half of a parallelogram. So it's half of base times height. And the very first thing we have to do with this particular shape is decompose it into those familiar shapes. Now, they've given us this dotted line, which stands for the height. So remember, we've got this right angle here connecting the base or one of the bases with an angle at the opposite side, so that's showing us that this is the height here. We know it's the height because it does make this right angle. But the nice thing is that this dotted line also gives us the height of this triangle and lets us separate out this particular shape. Now, we know then that if there's a triangle on this side here, and that this is not a right angle, so that means that we can break this into a triangle. And I'm going to draw a line the best I can, a vertical line. It's not going to be perfect, but you'll be able to tell what it is. And I'm going to draw my little right angle here, my 90-degree angle. So I know that this height is perpendicular to this base, because that's what that 90-degree angle signifies. So now I've got three shapes, two triangles, one rectangle, and I need to make sure I have the important information. So I always like to start with the rectangle. Think it's easiest. So I've got my rectangle here, and remember our area is going to equal base times height, and the base and the height are pretty straightforward here. We want the base of just the rectangle, so just from here to here. So I'm going to want to use this as my base. I do not want to use the 20 as the base of the rectangle because that is showing me the distance from this end of the trapezoid to this end of the trapezoid. And as I'm doing this, I'm sure you guys hear some barking in the background. That is my dogs outside playing. They are telling me it is time for dinner, but I think it should be pretty faint if you can hear it. So I will feed them after I finish this video. So back to this. We know our base is 12, and then we already talked about how the height makes this perpendicular line. This right gives us a right angle, and 8 is our height. So our area of the rectangle is going to be 12 times 8. So let's see. 10 times 8 is 80, and 2 times 8 is 16. And 80 and 16, that makes 96. And then we want to be precise. So centimeters squared, because it is two-dimensional. So we know that the area of the rectangle is 96 centimeters squared. So now we need to find the area of the triangles. So in this particular instance, they gave us the height already. So that's easy. I know the height of every single shape here is going to be this 8 centimeters because the side of the height of the rectangle makes up the side of the triangle. So that part is straightforward. That part is easy. But the base, though, that's where things start to get a little bit tricky. Now remember, we said this 20 centimeters tells us this whole distance all across this longer base of the trapezoid. Right here, it tells us that the base of this triangle is 4 centimeters because it's just pointing out this distance here. And then we already know that the base of the rectangle is 12 centimeters. And if the base of the rectangle is 12 centimeters on this side it has to be 12 centimeters on this side. That's how we define a rectangle, is these opposite sides are parallel and equal lengths. So I have my 20 centimeters, and I'm going to subtract 12 for the base of the rectangle, and I'm going to subtract 4 for the base of this triangle over here. And 20 minus 12 gives me 8, and 8 minus 4 gives me 4. So this over here is also 4 centimeters. Now remember, we talked about this in the past. That means that this is a regular trapezoid. It means that this angle here is going to be the same measurement as this angle here, and this side here is going to be equal to this side here. It's not always going to be the case with trapezoids, so you don't want to just assume. You want to check your math. Now let me clean this screen up a little bit so we can see what we're doing a little better. Alright, I tried to leave the area of the rectangle, but get rid of some of the other drawing and comments. So now we're going to find the area of the triangle. So the area of the triangle, remember the formula is going to be 1/2 of base times height. So we're just going to substitute the information we found in 1/2 times our base. Remember, we said the base was 4, and we said the height was 8. So since it's multiplication, we can use a commutative property and rearrange these any way we want. We can use the associative property, and we can either group the 1/2 with the 4, or I could go ahead and group the 4 with the 8. So let's try this. 4 times 8, well, 8 plus 8, that's 2 times 8 is 16. And double that again, and that gives us 32. So I'm going to find half of 32, which, well, it's kind of like we're going backwards, is 16. So the area of this triangle here is 16 centimeters squared. Now, since the area of this triangle has the same base and same height as the area of this triangle, I don't have to do any math. I know that this triangle is 16 centimeters squared too. But we're not done. We still need to add all of those together. So I'm going to add 16 and 96 and 16. I'm going to do 16 and 16 first because I already figured out earlier that 16 plus 16 equals 32. And then 32 plus 96. Well, 2 and 6 make 8. 9 and 3 make 12. So our answer to the area of this particular trapezoid is 128 centimeters squared. I'm going to take a moment to get this set up to show you the second part of the triad, which we're finding the area of a kite. All right, so that changeover probably didn't seem very long for you, but it took me a couple minutes to get everything cleaned up and set up for this new problem. So it should only take us a little bit longer to figure this out because we're going to do the same exact thing. We're going to decompose it into shapes we know, and then we're going to solve for those shapes. Now, a kite, what makes a kite is the fact that this distance here is always going to be symmetrical to this distance here. But on the other hand, these two distances don't have to be equivalent. Whereas if it were a square, and if it were a perfect square, and I were to do the diagonals, all 4 diagonals on a square would be equivalent. There's some other information that we could go into all about defining a kite properly, but I think for now that is probably enough. We really just want to break this apart into 2 shapes that we're familiar with. So we can see that this is made up of triangles. Now, some of you say you want to go ahead and you want to divide it into 4 triangles because you see those dotted lines and you can see, oh, that's easy. I can divide it into 4 triangles. But that means you have to find the area of 4 different triangles. And you could just as easily find the area of 2 different triangles. Now, you could just draw this line here, and I've got triangle 1 and triangle 2. Or you could put your that's not what that's supposed to be doing. There we go. Now it's erasing. You could divide it with a vertical line, and here is triangle 1, and here is triangle 2. You really want to make sure that you have the information that you need, that it's easy to find. And I'm just going to go ahead and use this one because I've got it set up already. So I have triangle 1. I'm going to label it triangle 1, and I have triangle 2. And if we recall, the area of our triangle is 1/2 base times height. So remember, the base of the triangle is the sort of flat side of the triangle. So even though my triangle here is sideways, if I'm considering this green line the base, I can still call it the base. And I want to use this green line as opposed to one of these other sides because this base already has this right angle to tell us that this line here is the height because it is perpendicular to the base and goes all the way across to the opposite vertex. So if I know that this green line symbolizes my height, I know that this distance here was defined as 3 inches and that this distance here was defined as 3 inches. So I'm going to put it all together, and 3 and 3 make 6. So my base is going to be 6. So I've got 1/2 times 6 times, we already identified this as the height that goes with that base, so times 4. So 1/2 of 3, or sorry, I've given you the answer already. 1/2 of 6 is 3, and 3 times 4 is 12. So 12 inches squared will give you the area of triangle 1. Now if I want triangle 2, it's got the same base as triangle 1, the same base right here as triangle 1 because it's made up of the same line segment. So area is going to equal 1/2 base times height. I'm rewriting it because it's good practice, it keeps us organized, and it helps form that memory. So area equals 1/2 times our base, which we said was this 3 and this 3 to put together, which is 6. And in this instance, the height is going to be this line here, and this is also 6. So 1/2 of 6 is 3, and 3 times 6 is going to be 18. So 18 inches squared. But I want to go ahead and put this area with this area. So the area of this whole kite is going to be 12 plus 18, which is 30. So our area equals 30 inches squared. So this was a little bit of a longer video, went over 2 different problems. Hopefully you can use this to go back and solve any of your other problems you're doing in your math Excel. And if you have questions while I'm out tomorrow, or I guess it's today for you, go ahead and email me. But you are expected to get this work done. So work with your partner, use your resources. You can use this video, you can use your book, you can use the step-by-step help in the Math Excel. But I want you to persevere, I want you to problem solve, and I want you to productively struggle through the work and get it done.